The WallySkater is my favorite of all the WallyTools setup tools. This simple tool has solved more problems than any other tool in my quiver. The WallySkater's function is to measure horizontal forces in your tone arm and to measure static frictional force in your tone arm bearings. Its proper use involves 3 different tests taken at 2 stages of the setup process. The first 2 WallySkater tests should occur before you align your cartridge, and the 3rd test is after cartridge alignment, but before taking any crosstalk measurements for the azimuth angle. The first 2 tests, measuring internal horizontal torque force and tone arm static friction, should be used on all tone arms, even linear tangential trackers or pivoted linear trackers. Actually, perhaps even especially so for these types of arms, as I've covered in another video. While the 3rd test is for normal pivoted arms only. In addition to this WallySkater instructional video, there are a couple other videos that you should watch to help you understand why its use is important for optimal vinyl playback. The video measuring tone arm behavior to ensure optimal cartridge performance, and the video on horizontal forces from the series of videos on the 7 alignment targets of optimal analog playback will be for you. Spoiler alert. The sonic benefits of getting your tone arm's horizontal torque forces and static friction under control are all related to the completely underappreciated cartridge motor damper. More on this misunderstood little wonder on a future video. To prepare for a use of the WallySkater, remove any mat you might be using, roll up your sleeves, and remove any hanging jewelry that might accidentally catch on the head shell or cartridge. Confirm your arm board is perfectly level. It is more important to level the arm board than the platter, though you can hopefully ensure both are level. If you are going to use a small, cheap bubble level like this one, take your reading and then turn it 180 degrees and measure again to make sure it agrees with itself. These cheap bubble levels are notoriously unreliable. The WallySkater measures horizontal force as a percentage of your vertical tracking force. So it is important to get out your VTF scale and confirm your targeted VTF is dialed in before we start using the WallySkater. Watch our video on overhang and VTF to learn why using a calibration weight and measuring with the height of the stylus at the right height above the platter is important for properly measuring tracking force. Immobilize your platter by taping it down or putting a wedge between the platter and the plinth. If your tone arm has a damping mechanism, completely disengage it. Place the base of the WallySkater over the spindle using the hole marked spindle with the printed side facing up towards you. Rotate the base on the spindle so that the center line is aiming right at your tone arm's pivot point. Make sure there is an O-ring on the ends of the lower beam and the upper beam away from the hash mark scale and insert into the appropriate holes of the post. Use a second O-ring to keep each beam safely in place. It is very important the printing on the post face the cartridge on assembly, so the print must face the beams. This is important because the peg on the bottom was intentionally inserted into the post at a very slight angle so that when it bears the weight of the 2 beams, their mass will torque the post into a roughly vertical position. Insert the post into the base at the appropriate mounting hole designated for outer groove area mounts, depending upon your tone arm length. Don't worry if your exact tone arm length is not listed on the mounting holes. Just round to the nearest match. For pivoted linear trackers such as the Reed 5A or Thales tone arms, don't use the linear bearing post mount. Use the 12-inch hole for outer area measurements and use the single inner area hole for the inner platter measurement. So simply put the pro hanger on the upper beam, and I suggest having the yellow thumb screw pointing outward, as that is the one that you'll be using more often. So with the pro hanger on the upper beam, take your yellow string with the open loop and put it over your finger lift. Make sure that the blue line and the yellow line are not twisted. So with the platter now immobilized, the yellow string attached to your finger lift, and your VTF properly set. Now we can adjust the height of the yellow string to have the stylus be 2 to 3 millimeters above the platter. Move the lower beam as close as possible, but not touching the head shell or finger lift. So not all tone arms come with a finger lift. So the solution for that is this aluminum wire that we include with the WallySkater Pro assembly. What you will do is you will wrap this wire around the arm wand or the head shell immediately behind the cartridge, and then pass this wire through the end of the yellow string. Twist the wire around itself to form a loop on a loop. This wire is very lightweight and non-magnetic. One final tug on that, and now let's take up the string. As explained in the WallySkater informational videos mentioned earlier, the purpose of the internal horizontal torque force test is to ensure that the tone arm will play nice when we go about the later task of aligning the cantilever. It is surprising how many tone arms are unintentionally internally biased to push the arm one way or the other. It is critical to know about this before setting the cantilever alignment. Now let's take our first measurement. Each hash mark on the beams represent 1% of your vertical tracking force expressed as a horizontal force. Since the plumb bob will always hang perfectly vertically, we will adjust the hanger's position so that the plumb bob aims at one of the major tick marks. Major tick marks are the thicker lines that occur every 5 hash mark increments. This will make it a bit easier to take our measurement figure. The hash mark that the plumb bob now points at becomes our reference mark from which we can begin counting. We count how many lines between the hash mark the plumb bob is pointing at, that's our reference mark, to the mark that the yellow string is intersecting. To accurately see this measurement, get your eye closer to the height of the lower beam and be sure that your line of sight is perpendicular to the lower beam, not from an angle to it. As you can see, we are measuring about 2%. This is our measurement of this tone arm's internal horizontal torque force at the outer area of the platter. This 2% is certainly acceptable. Give the head shell a tiny little tap to get it moving again, because we want to see if this measurement is repeatable. If the next result is different from the first reading, tap it once or twice more and then take an average of all readings. If the readings between these little taps are more than 2 or 3%, it suggests we may have a static friction problem with the arm. We will find that out in the next test. Perfect results in this test would have the blue string and yellow string lined up with each other. Typically, we don't have to worry about internal horizontal torque forces at or below 3 or 4%. Once you get up past 3% for high compliance cartridges, past 3 to 4% for medium compliance cartridges, and past 4 or 5% for low compliance cartridges, we need to take some action depending upon measurement results and tone arm design. Here's an example of an arm with an 8% internal torque force. This will be unacceptable because at the time of alignment of the cantilever, this tone arm will most definitely apply its torque force horizontally onto the cantilever, thereby skewing it from the perspective we will need for the alignment process at the null point of the Wally tractor, or any other protractor for that matter. If your arm has an exposed loop of wire, gently play with the position of that wire and watch how moving it fore or aft, or tightening or loosening the loop, will change the native horizontal torque of the arm. Very often, manipulation of any exposed wire can eliminate this unwanted force entirely. If your arm does not have an exposed loop of wire, but is expressing an unacceptable amount of horizontal torque, you will use the cueing lever during the alignment of the cantilever to avoid this torque force from causing you to unknowingly misalign your cartridge. I go into how to do this in the WallyTracker instructional video part 1, preparation and tips and tricks. Let's see how this tone arm performs on this same test at the inner area of the platter. Lift the cueing lever. For extra safety, remove the loop from the finger lift, or at least let out more length of the yellow string so that when we pull the post out of its mount on the base, we do not jerk the arm wildly. Move the post to the inner groove mount area hole. Slide the hanger so it is roughly over the end of the record. Bring the arm over to the inner area of the platter and reaffix the yellow string loop to the finger lift, or take up the slack using the yellow thumb screw. Lower the cueing arm. Push the lower beam as close as possible without touching the arm. Adjust the yellow thumb screw so the stylus is 2 to 3 millimeters off of the platter. Still the plumb bob and take your first inner platter area reading. Don't forget to do 1 or 2 more little taps to see if the arm behaves consistently. Again, the goal is for the arm to have as little of its own horizontal torque force as possible, so that it will not interfere with the cantilever alignment process. If you are getting wildly different results at the inner and outer area of the platter and do not know how to manage this issue, please feel free to reach out to us at WAM Engineering for help. The static friction test is very important. We want to know that the arm's bearings are sufficiently free from friction so that it does not impart a torque force on the highly sensitive cartridge damper during playback. As mentioned in our other videos on this subject, this damper is subject to a 6-to-1 lever arm, and it takes very little errant torque force to cause it to begin behaving suboptimally. Like all other tests with the WallySkater, this test is performed both at the outer and inner areas of the record. Since we are already set up at the inner area, we will begin our static friction test here. This test is performed by putting a horizontal force upon the tone arm by slowly moving the hanger in one direction and seeing how many hash marks the hanger will travel before the tone arm responds to that horizontal force by coming along for the ride. If your tone arm has viscous damping that you cannot disengage, expect the arm to take longer to respond to movements of the hanger. On the latest version of the WallySkater, we have added tick marks to the upper beam to make it easier to quantify the static frictional force. So, rather than the previous method of watching the total travel of the plumb bob, we'll monitor the travel distance of the hanger instead. Start with one edge of the hanger lined up with a major hash mark. And then simply move the hanger very slowly, perhaps even just moving it one hash mark increment at a time, watching the yellow string for movement. There, it moved. Now let's see how many hash marks the hanger traveled in order to get the arm to respond. We started here, so 10%. That is way too much. A condition like this will most certainly cause the cartridge to underperform. If your arm behaves like this, then I can very safely say that you have not yet heard your cartridge at its best. Of course, for demonstration purposes, I added friction to this bearing so you could see how high static friction measures on the WallySkater. Like the internal horizontal torque force test, there are limits of acceptability. Those limits are the same. 3% for high compliance cartridges, about 3 to 4 for medium compliance cartridges, and 4 to 5% for low compliance cartridges. If your arm exceeds these limits, contact us at WAM Engineering to discuss. Okay, lifting, disconnecting, slide the hanger over, move the post, move the arm, connect the arm to the yellow string, and lower. Adjust yellow string until stylus is 2 to 3 millimeters from platter and still the plumb bob. Now slowly slide the hanger inwards toward the spindle and stop moving it the moment the yellow string moves. count the distance the hanger traveled in hash marks. Again, we are looking for the arm to travel along with the hanger immediately, if possible. 1 to 2% is highly respectable, but watch out for the limits mentioned earlier. Hopefully your tone arm passed these tests wonderfully over the entire platter's playing area. However, I know quite a number of you are in for a bit of a rude awakening. In this incredibly sensitive domain of mechanical transcription that we live with, we need to be aware of these forces, dimensions, and angles at play if we expect to truly optimize our investment in our sound systems. Following this step, you are now ready to set the horizontal alignment of your cartridge on your head shell using the Wally tractor, and if you know your zenith error, use the Wally Zenith. We have written a few blog articles and videos on skating force and the necessity of applying an anti-skate force to compensate for it. We are going to really dial in that force perfectly with the WallySkater. As you've heard from us before, test records are perhaps the worst way to determine your anti-skate force, and the flat record skating test is highly variable and therefore not reliable. We know what the average skating force is. This has been well studied and documented over the decades. So we know what our average anti-skating force should be. The setup is the same as the other tests. Make sure your VTF is set correctly and the stylus is 2 to 3 millimeters from the platter. Here we are starting at the outer area of the platter. As we apply an anti-skating force, you can easily see the outward directing force being applied to the tone arm. As this is more than a 12-inch arm, we will be aiming for 9%. Give the head shell a light tap and check it again. Do this a third time if necessary and take an average of the readings. Increase or decrease your anti-skating to get the results in the ballpark. Don't worry about getting it spot on quite yet. At the inner area of the platter, the setup is the same yet again, and the post is in the appropriate hole in the base, and the measurement is done again with the stylus 2 to 3 millimeters from the platter. The tone arm closer, and the hanger must come closer. And now I will hook it up. Okay, move that a little closer, and then lower. Now you will see we are only at 7%. Give it a tap and check again. This can certainly happen where the readings do not agree with one another, inner versus outer. Having variable readings, inner versus outer, is fairly common. This sometimes due to the internal horizontal torque forces of the arm having variable characteristics depending on the location of the arm wand. Sometimes it is due to a poor design of the anti-skate mechanism itself, or it's a poor setup of the mechanism. I will address what to do in this very last scenario, that is when the difference between the two readings is much greater, inner versus outer, in the next video following this one. At 9% outer and 7% inner, the difference between them is not large, and the average of the two, of course, is 8%. We are really very close to our target of 9% for this greater than 12-inch arm. Remember, shorter arms will need as much as 11% anti-skate applied. Simply increase your anti-skate setting until the average of the two readings hits the targeted value. In this case, it will be 10% at the outer and 8% at the inner area of the platter. That gives us our average of 9%. Once you've achieved your targeted anti-skate value, perform a quick recheck of the static frictional force. We have seen a few poorly designed anti-skate mechanisms currently on the market that cause the arm to seize up when they are put into use. If this situation applies to your arm, contact your dealer for repair or replacement. And please let us know if you've found a defect on your end as well. There's the tests for your tone arm using the WallySkater. There's another video after this I'd like you to watch. That's the tips, tricks, and tricky situations video. I think there will be some important points in there for you, and especially if you're having some troubles, there might be some good hints in there. As always, feel free to reach out to us if you have any questions, and enjoy analog forever.